This video is about graphing functions. It's lesson 30 in your book on pages 179 through 186. Today we're going to talk about graphing linear equations. Now, a linear equation is an equation whose graph is a line. Makes perfect sense because see the word line right here in the word linear. It's an equation whose graph is a line, a straight line. A linear function is a function whose graph is a line. So remember, in order to be a function, it has to pass the vertical line test, which means that anywhere on your graph that you draw a vertical line, you should only be able to pass through your curve once, or line, one time. A linear function can be written in the form f of x, where f is the name of the function and x is the variable in the function, equals mx plus b, where m and b are real numbers. Remember, real numbers can include positives and negatives. It can also include fractions and decimals. Here we have some equations, and we're going to use tables to graph them. So it says graph each equation using a table of values that you design. After it is graphed, use the vertical line test to determine if it is a function or not. Okay, so here we have our first equation, y equals x. Now we need to create a table of values that will enable us to graph this function. So I'm going to have a table. I'm going to make mine horizontal just because it'll fit better over here. Okay, and I'm going to plug in some x values, and I'm going to get out some y values. Okay, now there's no set number of values that you have to plug in for x to graph an equation. However, I like to do 5. A good number to do would be like -2, -1, 0, 1, 2. That's a pretty good set to go with for a linear equation. Now I need to plug these numbers into this equation for x and get a y value so that I have an ordered pair. So if I plug -2 in for x here, I have y equals -2. So that means y is -2. If I plug -1 in for x here, I have y equals -1. If I plug 0 in for x here, I have y equals 0. And then y equals 1. And then also y equals 2. So see, I have a bunch of ordered pairs. I've got -2, 2. Oh, I'm sorry, -2. I've got -1, -1. I've got 0, 0. I've got 1, 1. And I've also got 2, 2. Alright, so now I want to graph this equation. So I'm going to take all these ordered pairs and I'm going to graph them. So here's my graph right here. Remember, my first ordered pair was -2, -2. So I go -2 and then down 2. So I have a point right here, -2, -2. You should definitely be graphing this and writing these examples down in your notes. My next ordered pair was -1, -1. So I start at my origin and go to the left 1 and down 1. Point right there. My next ordered pair was 0, 0. So I have a point right there at the origin. My next ordered pair was 1, 1. Positive 1, positive 1. So I go to the right 1 and up 1, draw a point. My next ordered pair was 2, 2. So I go to the right 2 and up 2 and draw a point. Now remember, we talked about how you know if you can connect those dots. Now if the points in between make sense for the function, then you can connect the dots. So could I plug 1/2 in for x and get 1/2 for y, which is where my line would pass through? Well, definitely, because y always equals x in this function. So I can connect the dots here. Excuse this line, it's going to be kind of ugly. There we go. Okay, so there's my line, y equals x. Alright, now let's do the next example. This next one is y equals x squared. So I want to design a table of values. So again, I'm going to do my horizontal just because it will fit better on this page. It's kind of squiggly. Alright, and I'm going to make up some x values and plug them in to get y values. So I'm going to do the same ones. I'm going to do -2, -1, 0, 1, and 2. Alright, so if I plug negative 2 into this function, I have negative 2 squared. So negative 2 times negative 2, which gives me a positive 4. So my ordered pair is negative 2, 4. If I plug negative 1 in here for x, I have negative 1 squared, or negative 1 times negative 1, which is a positive 1. If I plug 0 in, I have 0 squared. 0 times 0 is 0. If I plug 1 in, I have 1 squared. 1 times 1 is 1. And if I plug 2 in, I have 2 squared. 2 times 2 is 4. So here I have all these ordered pairs. I've got negative 2, comma 4. I've got negative 1, 1. I've got 0, 0. I've got 1, 1. And I've got 2, 4. Okay, now you can see that these y values repeat, right? We've got 1 and 1, 4, and 4. This is still a function because the x values don't repeat. Negative 2 only goes with 4. Positive 2 only goes with 4. So the x values don't have more than one y value they go with, so this is still a function. Now we're going to graph this function. Here's my graph. Remember, my first ordered pair was negative 2, 4, so I'm going to go to the left 2, because that's my horizontal, and then up 4, because my next number was a positive 4, and make a point. Alright, so I got a point right there. Alright, my next point was negative 1, positive 1, so I need to go to the left 1, and then up 1. My third point was 0, 0, make a point right there. My fourth point was 1, 1, so to the right 1, and then up 1. And my fifth point was 2, 4, so to the right 2, and up 4. Alright, now I need to connect these lines. I can connect them because I can plug 1.5 in for x and get an answer. So the values in between make sense. So I'm going to connect these. And when I connect them, I get one of these. And notice that it would pass the vertical line test. It's still a function. Alright, so in this example, we want to match a table with a graph. Again, stuff you need to write down in your notebook. We're going to use the coordinates in each table to match each graph with one of the tables. Alright, so on this side we're given the function, and we want to match this table with one of these three graphs. So first let's look at table 1. Here's the function. F of x equals 1/3 x plus 4. That's how they got these numbers. Now this says that when x is negative 3, y is positive 3. When x is 0, y is 4. When x is 3, y is 5. When x is 6, y is 6. When x is 9, y is 7. Okay, so I'm going to pick one of these points and I'm going to compare it to the graphs that I'm given. Okay, so let's start with the first point. When x is negative 3, y is positive 3. Okay, let's look in graph 1. Negative 3, 3 should be one of our points if this is the correct graph. So if I go to negative 3, it's about right here. And then if I go up 3, I'm about right here. Notice that point, whoops, right there. That point is not on this line. So table 1 does not go with graph 1. Now let's check graph 2. Negative 3, 3. So negative 3, about right there. Positive 3, about right there. That point is on the line. Now, just because one point is on the line doesn't mean they all are, so we need to check the next point. The next point is 0, 4. So when x is 0, y is 4. X is 0, y is 4. That point right there. That is not on that graph. So let's check graph 3. Negative 3, positive 3. All right, bingo. That one's on there. Let's check 0, 4. 0, positive 4. That one's on there. We are good. So this one goes with graph 3. Alright, let's check table 2. Here's the function, f of x equals 5x minus 1. That's how they got these numbers. For table 2, when x is negative 2, y is 11. When x is negative 11. When x is negative 1, y is negative 6. When x is 0, y is negative 1. Okay, so we're going to look at graphs 1 and 2, because that's all we have left. We've used graph 3. And check and see if these points match up to our line. So I'm going to start right here in the middle of the table with 0, negative 1. It doesn't matter which one you start with. Okay, so check out graph 1 right here. If 0, negative 1 is on this graph, there's 0, and if we go down to negative 1, point right there. So that one matches up. Let's check 1, 4. Go over to 1 and up to 4, and There it is. Alright, so those 2 points on this table also lie on this line. So the graph that goes with this function is graph 1. Now, by process of elimination, we know that table 3 is going to be graph 2. So look at this point. If we look at this point 2, 1, if we go over to 2 and up to 1, that one is definitely on graph 2. So that's good. Alright, on this next example that again needs to be in your notebook, we want to identify the domain and range of this function. Now, remember that the range is the y values and the domain is the x values. So first let's talk about x values. Here's our graph, right, so domain. And notice that the smallest possible x value our graph contains, the furthest to the left, is 0. So we know that we are going to have a set of numbers, and x is an element of all real numbers. That just means x is an element of all real numbers, such that, now again I said our smallest possible x value is 0. So that means x is going to be greater than 0. Now, our largest possible x value, so this arrow here, it implies that it's going off to infinity. So x is just going to be bigger than 0. It can also be equal to 0. So we're going to write a line right there. Alright, so our domain is x is an element of all real numbers, such that x is greater than or equal to 0. Anytime you list the domain and range, you're going to have this whole section right here. Range will be y's, but this just says that x is any real number as long as it's greater than or equal to 0. And we can tell that from the graph because the furthest to the left we go is 0, and the furthest to the right we go is infinity. Now let's do range. Range is y values. Again, we have to have y is an element of all real numbers, such that, alright, now check out our y values. Our smallest possible y value is 1. Y can be equal to 1, but it's never going to be smaller than 1. So this tells us that y is greater than or equal to 1. Now, if we continue this line on to infinity, we would keep going up and up and up and up and up and up and up. And so, that means that y can be anything infinitely as long as it is greater than 1. Alright, so our domain says that x is every number that's larger than or equal to 0. And our range says that y can be any number as long as it is larger than or equal to 1. Now, let's look at our equation and see if this makes sense. What numbers could we plug in for x? Well, since we're taking the square root, anything we plug in for x has to be positive, so it has to be greater than 0. That makes sense. Now the y is what answers can we get. So no matter what we plug in for 0, if the smallest number we plug in for x is 0, and we add 1 to it, the smallest y value we're going to get is 1. So again, y has to be greater than or equal to 1. Alright, and here's another example where we want to identify the domain and range. Again, we're going to use the correct notation, so we're going to start with the domain, and we want to say x is an element of all real numbers, such that, alright, now let's check out our x values. Those are our left and right. See this arrow that's going continuously this way, and then this arrow that's going this way? That implies that we could keep going infinitely in either direction, left and right. And notice here our number is x squared. There aren't any numbers that we can't square, so that means we can plug any number in for x. So we don't actually have to go any further than this, except to say that x is an element of all real numbers. So our domain here is x can be any real number, any real number at all. We can square any real number. Now our range. Again, we have to have y is an element of all real numbers such that, now notice our y's, we have up arrows here, so they can go on and on to infinity in the positive direction, but the smallest they go is 1. So y is greater than or